as we continue studying projectile motion in Unit 4, in the first part we only studied objects that went straight up or straight down in projectile motion. In this section we're going to take a look at what happens when that motion is occurring in two different directions, in both the X and Y direction. So this is part 2, horizontal projectiles. So as a reminder, for a projectile, anything that is in projectile motion has an acceleration of 9.8 meters per second squared on Earth, and that is usually abbreviated with a lowercase g. So here's our three types of projectiles. We have this one being dropped straight down. We have one that is both up and down, and here we're going to take a look at projectiles as they go sideways while also falling. So in this section, we're not going to look at something that's launched at an angle. We're only going to deal with things that are horizontal. So say a ball rolls off of a table, and the question would be like, where does it land? How far from the table does it land? So that's what this section is going to look at. And then next, we'll look at how to deal with angles in those types of problems. So here's the key with horizontal projectiles. This is really super important, is that if you have something that is moving in two dimensions, the horizontal and vertical components of that motion actually work independently of each other. So we'll do some video analysis to take a look at this, but you're going to see that the X component is actually moving at a constant rate. So there's a constant velocity. Because of that, we only use the equation x equals vt. We won't be using the little xo in this section because we're not dealing with two objects at a time, just one, so we don't have a use for that here. So X component, constant velocity. Y component, constant acceleration. So because it's accelerating, you could use any of the who cares equations at this point, but most often it's this one, the who cares for final velocity, so I added that there. Again, the acceleration is going to be a constant 9.8 meters per second squared, and again, you can still make the coordinate system be positive as it goes down, and sometimes that makes your signs a lot easier to work out. So the key concept in this chapter, objects fall at the same rate, and that means in the y direction, regardless of how fast they're moving horizontally. This is really counterintuitive. It's not something that you would expect. So my example here is, let's say you have two bullets that are fired. One is fired horizontally, and the other bullet is dropped at exactly the same time. Those bullets will actually land at the same time later. So they'll take the same amount of time to fall, even though one bullet has been fired from a gun and the other bullet has just been dropped. And there's a really great Mythbusters video that I have linked on my page and that we may watch in class that actually shows this experiment. It's really cool. So that's a really big concept in this chapter and something that you need to think about as far as multiple choice concept questions, because it's a little bit tricky because you don't expect it. Okay, so here's our problem solving tips for this section. We still have that 9.8 meters per second for our acceleration, but here's the deal. You're going to need to divide the variables into two different columns. You need X component variables and Y component variables. You have to do that every time. That's key for solving these problems. The thing is, whatever object is falling is going to hit the same the ground at the same time, whether that's that horizontal component or that vertical component. So time is a variable that's actually the same in both the X and Y direction. So normally the way these problems work, sometimes if they give you a really easy one, you can solve for a variable directly, but most often you're going to solve for time in either the X or Y direction, and then use that same time in the other direction to solve for the variable that they're asking for in the problem. So pretty much that's your problem solving strategy. You do it every time. Look for time and then use it in the other side to look for the variable asked for in the question. And we'll do a couple examples where we look at this. So here's my first example. We have a little guinea pig being fired out of a cannon, which is just adorable. And this cannon is going to fire horizontally. So like I said earlier, we'll deal with firing things at an angle on the next section. again, but here we're just going to have it fired horizontally to keep our problem solving a little simple. So the question is, how far from the base of the 120-meter cliff will the cannonball land? So this is not to scale, but here's my question, is from the bottom, how far out is this x going to be? So as I look at this problem, I'm going to split up my components into my variables into x and y components. In this case, there's nothing going up, everything's going down, so I'm going to go ahead and make down positive so I don't have so many negative signs that I'm going to have to deal with. So in the x direction, I know it's fired at 80 meters per second. And I know that because the problem says horizontally. So look for those words, horizontally or vertically, in a problem, because they're really important to understand how they're setting up the problem for you in these questions. So in the y direction, it doesn't look like they told us a whole lot, but because, again, they said it's horizontally, I can say in the y direction, there's 0 velocity because it wasn't fired up or down. Straight horizontal means it didn't have a y component when it was initially fired. Okay, they didn't ask us about the final velocity, so that's my who cares, and I have the acceleration due to gravity. So notice in this case, my acceleration due to gravity is 9.8 and it's down, and my little guinea pig is going to descend 120 meters. So both of these are down, so they either both have to be negative or they both have to be positive, but they have to have the same sign. So I went with positive to just not have to deal with so many negative signs in my problem. So I'm going to first solve for time. In this case, I don't know enough in the x direction to solve for time yet. So I'm going to use my y direction. So I'm going to put my numbers in my equation, and when I do, I'm going to solve for time, and time then is 4.9 seconds. So my 4.9 now is a time that I could use in the y or in the x. So I'm going to take that 4.9 and I'm going to put that in for time in the x direction equation. So I've got x equals vt because that's the only equation I can use for constant velocity. Remember, the v in that equation, by the way, is an average velocity, okay? It's not an instantaneous velocity like the who cares equations. So we're going to do 80 times 4.9, and we're going to find that apparently our guinea pig goes 390 meters, which would be really impressive for a guinea pig. But that's the answer for this particular question. So that's one example. So I'm going to give you guys another example here. So this time I've got a guy playing golf, and he's playing golf on a cliff, I guess. Maybe it's like Top Golf where they're up really high and they hit the ball. But again, we're only going to hit the ball horizontally because it makes the problems a lot simpler, and we're just starting out on these. So the question is, in this case, they told us where it lands, 120 meters downrange, which would be something I think you could find out at Top Golf. So when they say range, they mean this horizontal distance. So that's x in the x direction. So we want to know how high the guy was to begin with when he hit the ball, and we want to know its vertical velocity just before hitting the ground. Now, as a pro tip, whenever they ask you for the final velocity of a projectile, they always mean the instant before it hits the ground. Obviously, after it hits the ground, it's going to be 0. That's not what they want to know because that would be a really lousy problem. So they always want to know the velocity right before it hits the ground. So here, we're going to go ahead and put our variables in. We know we have that horizontal velocity of 30, and in this case, they gave us the range of 120. That means we have 2 out of 3 variables in the x direction. So we can go ahead and solve for time in the x direction. So when I do that, I find my time is a nice even 4 seconds. So I can use that 4 seconds now in the y direction to actually solve the question that they're asking me. So they want to know the height. So I'm going to go ahead and put my who cares variables in here. And when I do, I've got my who cares equation. Again, this is normally the equation that's used in these types of problems. Because it doesn't have a vertical initial velocity, this term is going to cancel out. And all I have to do is 1/2 9.8 times 4 squared to get my height. Now notice I'm saying it's 78.4 meters high. I could say it's negative 78.4, but I think that would mean it falls negative. Again, you have to be careful about the phrasing. It's kind of weird to say, how high is the cliff? Negative 78.4 meters. That doesn't make any sense. So if you said, how far did it fall? It fell, its displacement was negative 78.4 meters, but I'm not sure we normally talk that way when we say how high things are. So that's pretty much how your horizontal projectile problems are going to work. So our part B on here, find the vertical velocity just before hitting the ground. So this is actually a straightforward who cares question that once you know the time involved, it's just a regular who cares equation. So we're going to use who cares for x in this case. We could have used any equation at this point that has final velocity in it. This one just looked pretty simple. So I'm going to say that for anything, if it's going to fall 4 seconds, its final velocity is going to be approximately 40. Because remember, we talked about v is proportional to gt. So if g, the acceleration due to gravity, is 10, you can take 10 times the time, and that's going to tell you approximately how fast it's going. So here we have a little more of a precise number because we used 9.8 for g. But remember, you can do those quick estimations if you use 10 for the acceleration due to gravity. Okay, so the main ideas in this one. So the biggest thing is to understand that the horizontal and vertical components of a projectile act independently of each other. Velocity is constant in the x direction, acceleration is constant in the y direction. Time is going to be the variable that's going to allow you to go back and forth between those two components. It's the same in each direction. So anytime you're doing a problem like these, you're going to solve for time first and then solve for whatever the required variable is. And that's it for this video. We'll look for more of those problems in class. Thanks for watching.